Yes.
You study?
Yes.
I have to.
Why?
It's a course.
I don't study.
Sure.
Oh, but I'm not studying.
For this class.
Why you do?
I don't want to get.
If I did that
I
every
study
time,
my
The day
math.
before a soccer game, do you go out and practice extra, or you say I've been practicing for 3 weeks?
Claire put it out of her head that she did.
Yep, sure do. No, you don't. You just show up and do your thing. The practice is.
But what if you don't know how to study?
So, yeah, that's a 0. It's not a D. Okay, so recall what you must now check first. You must check continuity now. Ensure that it's not an improper integral before you mindlessly plow ahead. And you should be checking continuity. In this case, is it continuous over the entire interval?
No.
No, you must use improper integral. Limits.
That's a match.
Ian, hey, great job on the musical, by the way. All you people. Yeah, that's why I said all you people. Nathan, great job.
Thank you.
You're the best one doing set stuff. Except for Ian.
Ian's not doing set stuff.
You
you
do
didn't
like
like the lights.
Yeah, I never noticed the lights, which is good. What do you want?
I want to throw them.
Oh, look over there, please. Behind you. All right, I was taking attendance. Good thing I waited because he just showed up. There we go. Strangers in the night, oh, exchanging glances. Spring sports start today. Is everybody going to be fighting it out for the gym time or what?
Yeah.
That's
So you guys can have it. I hope so.
We're at 3, so
You guys have a big number 3? So when are we? That means we don't get together.
the track is actually clear outside. Well, I saw it a few hours ago and it looked like it was fine.
Well, then it's still clear stuff. Actually, I don't mind that.
Is this recording? Yes, it is. Perfect. Okay. Very good.
I don't like how this maybe I should just run.
Okay, now we're. So that's the plan.
Are you serious? No, that's so funny. Testing. Testing already.
What'd you get for 16? I got 3. How about you?
Negative 3. Oh, but you minus it.
I got positive 3.
Wait,
Oh, right.
Isn't it minus a negative?
Yes.
The antiderivative,
It's
the
negative.
antiderivative should be negative? Oh, okay. All right. I got 3. Let's see, so here's 1. So this goes to drawing things pretty well.
What if we want?
So here's sine of 2 theta. That's our rows, yeah? And it's crucial that you do it well, because if you do that, you're going to be doing things wrong. So the thing is this, you have to consider. These are both starting at 0 and going to get bigger. Which one gets bigger faster? The sine of 2 theta one, yeah? So at this, for example, the sine would be outside. The blue is bigger faster. And so it should be outside. And then it comes in. Oh, darn it, I did that way. That's actually pretty doggone important, that you have it correctly drawn with the correct outside and inside. That says inside both. Oh, I didn't. Did I erase the area you're supposed to be finding? 5 is the area inside both. You can't use symmetry to an extent. Yeah, if I were saying, all right, I got to stay inside, you can use a calculator, but not for the intersection points. Staying inside, staying inside, staying inside feels like it's staying inside the sine because it's the inner function. But the minute you get there, then it's going to switch over to a different staying inside, staying inside. So it feels like there are 2 regions, and then symmetry.
Can we use our calculator to find when they intersect?
You cannot use your calculator to find where they intersect. You can use it to evaluate the integral. Use an identity. Okay, that's hard to solve, so instead use an identity. You may use a calculator to evaluate the integral once you're done, but I get that you're looking for 0, obviously, but also when 1 equals 2 cosine theta. So when cosine theta is 1/2, which is that? Pi over 6 or 3? 3. That said, you can use symmetry between the right first quadrant area and the left second quadrant area. But even with symmetry, you'll need two angles. One for the green, one for the purple.
What was the average score on the test?
We haven't finished because some people haven't done those extra 5 questions, which we'll do first thing tomorrow. They were solid. The average on the free responses are probably in the 7 or 8 ballpark.
Does that mean I got a 0?
How, I don't understand the logic.
There's always got to be an outlier or something.
Yeah. Does there have to be?
Someone has to.
No, not true. You're saying, in essence, you're saying an outlier is common. It's kind of contradictory.
Well, at least one outlier. It's statistically
All right, did you get something like 0.4 or something?
Oh,
Yeah, something. What did I get? 0.4606. I would practice putting it in your calculator. It's not a layup. And then once you get done with that, we'll talk about noting notes. The LCT. I was thinking about doing some kind of song layover to the tune of OPP. Who's done with LCT? You apparently, see, somebody knows that song, but most people I figured didn't know that song, so never mind. All right, are you ready? Yes, let's go here. All right, so first of all, your notes are kind of all over the place. I made my copies, then I was rereading my notes, and I felt like my notes 2 years ago were better. So I'm going to do a little switchy switch. Would you get to your notes, please, and go to the back according to the hole punch? That's a better introduction to the idea, and then I'll go to the front. All right? Apologize. I know that'll make you look crazy. That's partially why I did it a little bit. But so here it goes. This, by way of introduction to the LCT, or the limit comparison test, it goes like this. This is the idea behind it. Say some sequence of infinite terms A sub n converged, and some other series B sub n is a series that's like it, but all terms are exactly half that of the A series. What would you say about the convergence of the B series? If A converges and B's terms are all half of A terms, then does that imply that B would converge as well?
Yes.
Surely, yes. Okay. So you would, in essence, you're saying half of a finite series is finite. From that, we're concluding that B converges. All right, let's say instead of half, we said B's terms were double. So A is a converging series, and B is a series with all terms that are twice that of A sub n. Would that imply that B converges, or now B's getting big and it would diverge? Still converges because double finite is still finite. Double infinite is something else, but double finite is finite. And that would imply then that even though B is bigger, B still converges. All right. Taking this to the little more extreme, say A sub n converges and B is a series with all terms 100 times that of A sub n. What would you conclude then? Still converges because 100 times finite is still finite, and therefore B sub n converges. All right. Now, if we were to generalize this, then we could say that if A sub n converges, And the limit of the comparison of A to B is some constant. Now, you could say then that the terms A to B is ratio 1 to 2, or 1 to 3, or 3 to 1. In other words, the terms are proportional. That's another way of saying it. The ratio of A to B is a constant. Now, it's got to be the case that constant is between 0 and infinity. I'll explain in a minute. Okay? Then B sub n must converge too. If there's proportionality between the terms and A converges, then surely B must converge. Because double finite is finite, or C times finite is finite. Yay? What if there's proportionality between the terms and A diverged? If B was just like A, except maybe multiplied by a constant, and A diverged, then B must diverge. That would imply that B diverges. So we could say that if the terms are proportional, the two series behave the same way. And when I say behave, I mean converge or diverge in a similar fashion. All right, now then, one more thing about that 0 and infinity stuff here. What about if the limit of the terms was 0? As you went on, the ratio of terms, now that doesn't mean the terms are both 0. It just means the ratio of the terms approach 0. Remember, it's a limit after all. What would that imply is growing faster, A or B? B. B is growing faster. Now, if B is growing faster, then there's not really this double finite equal finite. They're not really similar at all. Not similar at all. And so we couldn't say they behave the same. They probably don't, in fact, behave similarly. That doesn't mean they behave opposite. It just means I don't know what each one is doing. Okay? Likewise, if the limit was infinite, what would that imply about the series that's going faster, the sequence that's going faster? If that's the case, if the ratio of the terms is going to infinite, which one's growing faster, the top or the bottom? The top is going faster, and again, there's no relationship between the two. All right, but if you take a comparison between two, and there is a double relationship, or a triple relationship, or even a 100-time relationship, well, then you're in business. All right, now this is the idea behind the limit comparison test. It is a lot like the direct comparison test, in that it's a comparison test. You choose one it's like, and you run this test on it. The beauty of it, however, is that it is better than the direct comparison test. The direct comparison test fails exactly half the time. If it's not perfectly set up to be, less than converging case, then it's inconclusive, and we don't know it. Limit comparison test, that doesn't happen. If there is no screws up, if you chose well, the test will work. So it goes like this. This is the limit comparison idea. They will ask you about, oops, I didn't check that was a highlighter. They will ask you, that's purple. They ask you about a series A sub n. Now you're going to compare it to B sub n. And that'll be like the series, but without the +1, or without the +3, without all the mumbo jumbo, stripped down to its just basic power elements, all right? Now this is how the test runs. After you choose what to compare it to, you take the limit of how their terms compare, and you hopefully are going to show that, hey, the ratio of these terms is 1 to 1, or 2 to 1. Some number that's neither 0 nor infinity, so you can establish their growth rates are the same, or at least proportional. Now, after you run that limit and find the limit, then the conclusion the conclusion is usually 3 statements. Feel free to whine about the writing, which I'm sure you will, okay? It goes something like this. Because the limit you found, blah, is between 0 and infinity, both converge or both diverge. That's the first sentence. Now, I'm going to, out of experience, 10 years of teaching this, it's always the same corner cutters that make me bonkers, okay? Notice I didn't say not both converge or diverge. What's the one little difference between my sentence and that sentence? Both converge or both diverge versus both converge or diverge. There's missing one little both. Now this statement is important. This statement is stupid, okay? It's saying both series converge or diverge. Well, of course both series, what else can they do? There's only 2 choices. They can either converge or diverge. So to say they both converge or diverge, that's moronic. Of course they both converge or diverge. What the idea is that both converge or both diverge, and parenthetically you could say together. They behave similarly. They don't both converge or diverge in their own way. They both converge or both diverge in a similar fashion. All right? That little extra both implies that they're linked. Now, the second statement then is to say, hey, the series I compared to, B sub n, either converges or diverges, depending on the case, because of blah, blah, blah. The thought process being that because the limit is 2, both converge or both diverge. B converges, and so A must converge as well. So the series must converge or well. Now, that said, let's see what this looks like in action, and you'll see what I want to see. Number 8 on the homework is, you can scratch it out in the problem set and get this in your notes, please. Number 8 is this series. Now, surely because of that plus 1, but otherwise it's a lot like 1 over n, yay? Now, I don't know if you need to write this down because I'm about to address what doesn't work, but would the direct comparison test work? Is n plus 1 greater or less than 1 over n? Greater. So what about 1 over n plus 1? It's less. And what about the infinite series? 1 over n plus 1 is less than infinite. What does that tell me? Nothing. It tells me inconclusive garbage. Less than infinite. Great. It might still be infinite and just slower, or it might be finite. So this is direct comparison test is inconclusive. Now I told you a second ago, the limit comparison test doesn't have that issue. It will work every time. So it goes like this. We're going to compare the series in question, 1 over n plus 1, to 1 over n. How do the terms compare? As we go down the line, obviously the terms aren't equal, because that plus 1 means something. But do they behave in a similar fashion? Well, what's the limit? What is the limit equal to? And behavior-wise? 1, yeah? And that is to say that they're pretty much one-to-one in behavior. They're not equal to each other, but as you went down the line, if you talk to 1,000,000,001 over 1,000,000,000, they'd be pretty much the same. And so they should behave exactly the same way. That's where our conclusion then will go. Something like, because, actually I don't need to know, I'm not at the conclusion yet. Because that limit of 1 is between 0 and infinity, that's implying that there's some proportionality between the terms, and both converge or both diverge. which is to say they behave in a similar fashion. Okay, so they have to, they're linked. Well, 1 over n, does it converge or diverge? Diverges, you must say why. Why? It's the harmonic series. You could also say the P series. Harmonic's my preference. Okay? All right, well, because the limits between 0 and infinity both converge or both diverge. 1 over n diverges, and so we can conclude that 1 over n plus 1 must diverge. Or diverge as well, if you like. Do you understand the thought process? All right. Let's, oops, how about that? Okay, why don't you try 10 on your own then? Try 10.
Why do we even learn the direct comparison test?
Good question. I'll come to that later. If the limit comparison test is so superior, why even show it? And that's a fair question. Feel free to talk it over if you're math and English.
Comparing these two.
So what do you think? Oh, actually, let's go here. So this is my thought process. I say this is like something like, and it's all about n behavior, or looking at the greatest power terms. So the top is like either n or 2n. Over the bottom greatest power is n squared. So to answer your question, I would compare it to 2 over n.
So it's like the direct comparison test where you write like compare to or by and then the other series. So do we have to do that for these problems too?
So you should say what you're comparing it to. You should identify what you're going to compare it to. But the beauty of the limit comparison test is all that inequality work that you'd have to show, this is less than that, which would be really freaking hard here, by the way. That inequality work to show or establish that this is less than 2 over n, that would really be hard. Limit comparison test, none of that is necessary. You don't have to do any of that stuff. All you have to be able to do is evaluate the limit. The limit work, that's all up to you, how fast you do it. If you clean it up a lot or clean it up not at all, I don't care. Let's get the limit right. Ready? Or not yet? Okay, so we walked through how we might compare it to 2 over n, although you could try something else, and I'll talk about that in a second. What does the limit come out to if you compare it to 2 over n? It is 1. That is to say that there's pretty much a 1-to-1 match in proportionality between the terms. So they have to be like each other in terms of behavior. So because the limit is between 0 and infinity, both converge or both diverge. Well, 2 over n converges or diverges? Diverges. Why do you say that? It's a harmonic. It's a multiple of the harmonic. You don't have to say it's a multiple of the harmonic. Harmonic, and therefore the series they ask about must diverge also, or just diverge. You follow? What if the Mathematico next to you, instead of using 2 over n, compared to 1 over n? What is the limit in that case? If it's 1 over n, then this limit would be 2. Would the conclusion still stand? Yeah, everything would go fine, so that's fine, no worries. It's still proportionality. What if the mathematical on your other side compared to 1 over n squared? What's the limit? If I had a 1 over n squared here, then it would be n squared coming up. I'd have n cubed over n squared. The limit would go to infinity, and therefore there is no comparison between the two. It's not like you could say both now converge. There's no comparison between the two. You're comparing a converging to something that's totally unlike it. So it fails. You with me?
Yeah.
All right. Last but not least, would you do 12, and then I'll answer on this question. What about the DCT? Why do we even learn it if the limit comparison test is superior? Try 12. I do. The beauty of this is that if you stink at limits, which at this point, how could you stink at limits without knowing it? Even if you blow the limit, you'll still get the correct conclusion in most cases. If you're off by a constant or something like that. Although I would obviously take off for not being able to evaluate a limit correctly. You comparing to 1 over 3n all cubed, or 1 over just 3n cubed, or 1 over 27n cubed, or just 1 over n cubed? Okay, 1 over n cubed is fine. If you go 1 over n cubed, it's very logical. Be careful with your limit. Is it 1 or 1 over 3 or 1 over 27? 1 over 27, all right. And I do care that you get the limit right. If you did 1 over n cubed, the limit is 1 over 27. That said, there is a proportionality between the terms, and so we can conclude convergence or divergence in the same fashion because that limit of 1/27 is between 0 and infinity. Both converge or both diverge. What does 1 over n cubed do? Converge or diverge? It converges. Why? Geometrical P. P series. P series, P equal 3 is greater than 1, and we can therefore conclude that if they have to behave similarly, and the first one converges, that the one they ask about, 1 over 2 plus 3n cubed, must converge also. That's what it's like. You with me? Yeah. All right. Limit comparison test is vastly superior, most useful in 95% of the cases. Direct comparison test is sometimes better, especially with anything like natural law. If you tried this series, for example, which we did earlier, the limit comparison test would actually fail there. LCT fails. If you use the direct comparison test using square root of n over n cubed, it flops. So there are some cases where the direct comparison test is superior, but not many. Okay? This works. Okay, that's it. Questions on set 131. The last one and one. One in the last one. 1 and 24. 3. 1, 24, 3. Oh, did you say 3 or was it 23? Both of it? 21? Okay. 14. All righty, here we go. All righty, 1. The old optimization. So you've got a rectangular prism with an open top, no lid, which makes things much easier. And it's 4 wide, but the others aren't named. Did you call them X and Y or what? How about X and Y? What do you think? Okay, sounds good. All right, I think the volume is set to be 36, which there's an infinite number of combinations like that. But they want to minimize cost. Surely we can't minimize cost until we have a cost equation. So here we go. That's the hard part, getting the equation. Please, I beg you, use units as a guide. It'll help you greatly. The materials cost $15 per square meter for the base. So the base would be $15 per square meter, but surely that's not cost. That's cost per square meter. So we need to multiply that by how many square meters in the bottom? What's the square meters in the bottom? 4x. If I did that, the square meters would cancel and I'd have cost. Beautiful, wonderful, wonderful. All right, the sides, they say, are $12 per square meter. And I would have to find the amount of square meters to the sides. What's this side? 4y. And what's this side? xy, yay? And there are 2 of each of those. Are we cool with that? That's square meters. Square meters cancel. Let's clean that up and then we'll deal with the next problem that comes over. I get 60x plus 96y plus 24xy, if I did my math correctly. Right?
Yes.
Okay. Now, what's the next order of business or the next problem we run into before we throw calculus at this? Yeah, 2 variables, 2 independent variables, and that's bad. So what's another relationship? Volume, yeah. If the volume, which is 36, is 4xy, then it seems like we can find y or x. It's the same either way. So y is 9 over x, yay? Is the implication of that. So that means our cost equation is 60x plus 96 times 9 over x plus 24x times 9 over x. Always clean up before your calculus. So the cost function is 60x plus, let's see, 96 times 9, that's 810 plus 54, so 864x to the negative first. And 24 times 9 is 180 plus 36, so that's 216. The x's drop out. There's my cost equation. Do you agree? All right. Now you can probably run your calculus fine. If you want to min, then you want to find when C prime does what? C prime does those. Negative is 0 first for critical numbers, and then verify that C prime is going negative to positive. Okay, so find your critical numbers, and then cha-cha-cha. You good? You're good. 24. I'll let you finish that, and then we'll go on to 24. Yeah, all right. keep in mind also that while you're finding the x, they ask her what's the minimum cost. So once you find the x, you need to put it back in your cost equation. 24.
If we don't have the derivative graph,
It never switches sign, or never zero, or goes negative to
I
positive.
know looking like
60 minus, yeah, I agree. That said, this is plus, yeah. No, it's minus. So x squared is 64 over 60, so x is the square root of that. I don't know if that comes out. Well, it doesn't matter. It doesn't have to be 0 there. It just has to change signs. You can have critical numbers where it's 0 or undefined. So I don't know what your issue is, but I feel like that's good. Okay. Oops, that's not 24. Nathan, are we good? Okay, great. 24. Question on 24 still. Does anybody need 24?
Yes.
All right, 24. All right, I think I changed it to sign, yeah?
Yeah.
Or just sign?
Yeah.
So 0.2 to 1.4 of sine, estimating this via the trapezoid rule. Are we cool? Alrighty then. Do you remember what goes out front? Okay. Remember the trapezoid area formula is this. The 1/2 can be pulled out front. The height is really these, and it's delta x. And the bases, or the parallels, there are the functions. So, the delta x is, what is delta x? If I'm taking the region of 1.4 to 0.2 and dividing it into 4 chunks, then what's the delta x? 0.3. All right, so you have 1/2 of 0.3 factored out for each trapezoid. And then the inside, the first base, you remember, happens only once. So it's a single sine of 0.2. Trapezoids don't have this right, left mumbo jumbo. It starts at the very left edge. Now the next point would be how far in. If it started at 0.2 and I'm delta xing 0.3, then my next x is 0.5, but it happens part of 2 different trapezoids. So it's 2 sine of 0.5s, and then 2 sine of 0.8s, and then 2 sine of 1.1s, until I get to the final edge of 1.4, and that's just a 1 sine of 1.4. We'll have to review Simpson's rule sometime also. It's like this, but a little different. All right, you with me? Slap that into your calculator, and pow. Whatever that comes out to be, that's your first part. Then let's talk error bound. Now, I'm not throwing error bound in here, my extra note to torment you. It's meant to prepare you for Lagrange error bound, which is a series idea that is a lot like this. And so I have a point to this. It's not just torture. Error bound for trapezoids is less than b minus a cubed over 12m squared times m. Some folks call it k for some reason. But a is either a max or an upper bound for the absolute value of the second derivative on the interval. Right? So if f is the function you're finding the area under, then f is sine, f prime is cosine, and f double is negative sine. You with me? All right. Now I want to find the max of the absolute value of that. So I'm going to slap some absolute value on that. And the max on 0.2 to 1.4. Sine looks like this if I took the absolute value of it, right? Yay? Where's 0.2 and 1.4 then? I know that's not radians, so it takes some thought. What's pi over 2, the peak decimal what? About 1.57. So wouldn't you agree that the max of sine on that interval would be the sine of 1.4? And the assumption is, though, that you don't know the sine of 1.4. That's what you're trying to sometimes estimate. So instead, we say we know that regardless of what's going on here, I know it must be less than or equal to 1, because all sine and cosine values are less than or equal to 1. So it's logical and accepted to choose an m value of 1. Therefore, my error is less than or equal to, what's b minus a for this problem? It's the region from lower to higher, so 1.2 minus 1.4, rather, isn't it? Maybe it's 1.4. 1.4 minus 0.2 cubed over 12, what's n? 4 squared times an m of 1, we said. Whatever that comes out to be, that's your error bound. Key word is bound. It's not the error. You don't know the error. If you knew the error, then you know the exact number. And you don't know the exact number. It's a bound for the error. Okay, the error is not more than that. Okay, you follow? Okie dokie. 3. Question on 3. Find the length of the. This is the second time the other class asked about this, and I cannot for the life of me figure out why. So for parametric, isn't arc length this bad boy?
Yeah, I just didn't have it cleaning up at all.
You what?
I didn't have it cleaning up at all.
Oh, did you say you had to do it without a calculator?
Yeah.
Oh, that's your question. Okay, there you go. Okay, well then let me catch up to you. Sorry, I hope I didn't unnecessarily be mean to you, and that it's not clean upable, which is not a word. 6 times 1 squared plus 8 times 3 halves, that's 12, t to the 1 half squared. Let's see if I agree that this is hideous and I was mean, or you're being a wuss. Let's see, t squared minus 2t plus 4. Then 140. Sounds like your conclusion might
I
be.
done goofed. That's my bad.
Okay. That said, I'm not convinced it's super easy yet, so let's see. 36. If I take out a 36.
And it's wait, isn't it, it's not 6t minus 1 squared.
It's the derivative squared.
And the equation is 3t minus 1 squared. So
Right, so the derivative would be 6 to the t minus.
6t minus 6 squared?
Oh, sorry, I have my parentheses in the wrong place. I did not multiply in.
Oh.
I kept 6 outside.
Okay.
Because I was thinking maybe I'd be able to take a common factor out. But I did have it written badly. So if I take a 36 out, and this guy's just t squared minus t plus 1, and this guy's 4t, I think. Am I wrong in thinking this is going to be clean? Minus 2t, or plus 2t? No, it still works. Delightful. Isn't that the square root of t plus 1 quantity squared? So you're integrating t plus 1. So that's 1 half t squared plus t from 0 to 1. So it worked out. Calculator, schmalculator, who needs it? Not you. Not you. 6 times 3 halves. I get 9. Yay. Anybody still need 23, 21, or 14? All right. Let me know if you do. I will be happy to further do that. You taking it out? If you're not easily distracted, I'm fine there, but if you gotta go in the hall, whatever.
Why do we never do the other?
If you want to plug headphones or whatever you want. Yeah, that's good. Let's just see how loud it turns out. And if it's not loud, we're in the hall once everybody's here.
Are we doing it tomorrow with the other 5 hours?
Yes. There's no lesson on Texas practice tomorrow. Have a lovely day, people.
Sir,
Yes.
can you,
That's
can you
him.
record me as well, please?
Why don't you sign up earlier? Yes, I can require both of you. Check.